Recall that some systems of equations have infinitely many solutions, and some systems have no solution. Systems with infinitely many solutions. If you get an identity when you solve a system of equations, then the system has infinitely many solutions. For example, an identity might be 2 equals 2. On a graph, what we'll see is that the lines are the same. Systems with no solution. If you get a false statement when you solve a system of equations, then the system has no solution. For example, a false statement might be 8 equals 4. On a graph, you'll see parallel lines. This leads us to problem 4. Systems with infinitely many solutions or no solution. How many solutions does each system have? Part A. X equals negative 2y plus 4 and 3.5x plus 7y equals 14. Notice in this system, x is already isolated for us in the first equation, so we can substitute negative 2y plus 4 into the second equation right away. So we find 3.5 times the quantity negative 2y plus 4, shown here in red, plus 7y equals 14. As we distribute and simplify, we find that 14 equals 14. It's an identity. So we can state the system has infinitely many solutions. Part B, y equals 3x minus 11 and y minus 3x equals negative 13. Something should stand out right away, and that's the coefficients of x here. The top equation is in slope-intercept form, and we can see that the slope is 3. The second equation is nearly in slope-intercept form, and if we were to rearrange it so it was in slope-intercept form, we would add 3 to each side, and we'd have y equals 3x minus 13. Parallel lines leads to no solution. But let's continue with the technique shown here. If we substitute 3x minus 11 for y in y minus 3x equals negative 13 and simplify, we find negative 11 equals negative 13. So this system has no solutions. Your turn. How many solutions does the system have? 6y plus 5x equals 8. 2.5x plus 3y equals 4.